5 bushings, 4 all-thread, 8 wing nuts, 6 large washers, 8 small washers, and some plastic. $30. In about 60 seconds, you'll learn how much the real Dowelmax costs. And at the end of the video, you'll get to see its joinery put to use in a foldable Murphy desk. It seemed too simple at first. There had to be a catch, some design element that I wasn't seeing that made the Dowelmax. But it turned out I wasn't missing anything. Its genius is right there in its simplicity, hidden in plain sight. 3 simple shapes, a couple thumb screws, and some spacers. Could my teensy-weensy printer, with a build volume barely capable of printing a baseball, spit me out a Dowelmax? That's the question I set out to answer. And it worked. I don't own a Dowelmax or any other doweling jig. Therein lies half the motivation for setting out on this project to begin with. I needed, no, let's be real, I wanted an easier, more reliable means of creating a variety of strong joints. Who doesn't? The Dowelmax checked all the boxes, all except one. Yes, it's a bargain compared to the Domino, but it truly surprised me when I learned that those 3 simple bodies, couple thumb screws, and spacers would cost me $295. So that's when I turned to my little printer that could and asked, "You up to the challenge?" With little printy down to clown, this perfectly orthogonal footage courtesy of Perilla Works, and the very minimal dimensional information listed on the Dowelmax website, I started reverse engineering each of the 3 pieces in Shaper 3D. These guys are not a sponsor of this video, just a fun-to-use, easy-to-learn modeling program for desktop and iPad. I certainly didn't get the design right on the first try, not even close. Thickening walls and enlarging fillets. Low infill density. Widening the extrusions to accommodate larger washers that will more evenly distribute the clamping force from the wing nuts. The means of holding the spacers needed to be changed. There's the spacer. I didn't need to reinvent the wheel by printing my own fasteners when they're a dime a dozen. Because of the ball and socket joint down here and how unique this specific size of fastener and ball and socket joint is, I decided to keep a threaded fastener 3D printed down here. Improving thread tolerances. Failed prints. The most notable difference in form between my version and the original Dowelmax is the geometry and bore styles in the L-shaped piece. The metal threads lining the Dowelmax blind holes are enough to accommodate the clamping forces caused by the thumb screws. That same concept, in plastic, didn't work so well, so I opted for through holes, all-thread, washers, and wing nuts, same as here. All right, here it is in its edge configuration. And we'll change into its face orientation now. We'll go on there like that eventually. First we need to put this hardware back on. There are 2 layers of washers here only because I was unable to find a 1 wing nut, 1 washer combination that had enough grab on both the wing nut side and the Dowelmax side. One of my goals here was to spread out the clamping force from the wing nut as best I could across this plastic face here. 2 washers smashed together met this requirement. There's only 1 layer of washer in this location because the size of the flange only allowed for the smaller sized washer to fit. This can always be adjusted later if need be. A friend of mine commissioned me to make a Murphy desk for his home. After a couple back and forths, here's the design we settled on. The weight of the table in its folded out position is supported by these 2 legs that, when not in use and the desk surface is down, fold inward toward the wall via these hinges, leaving a shelf about 6 inches wide against the wall. When the legs are not in use, the weight is supported by floating shelf hardware that's hidden behind these vertical pieces that are anchored to the wall. The legs were a perfect opportunity to put the Dowelmax light to use. All right, so I got it all marked out here. I'm going to use holes 3, 4, and 5. Holes 2 and 3 there, and holes 2, 3, and 4 there. All right, so here's my setup. And this is actually just a support board because the width of this leg piece would only accommodate one of the 2 clamps. So I had to bring a support piece over here, which is fine. But I'm preparing to drill 3/8 inch hole to accommodate a 3/8 inch dowel bit that's 2 inches in length. And I've set my drill bit depth to a little over half of the dowel length, about 1 1/16. So that's good to go. All I need to do is pray that this thing doesn't move as I'm drilling the holes, and kind of hold the thing in place with my hands as well, and hopefully that helps. We'll see how it goes. All right, here we go. I'm going to use holes 2 and 3. One hole down. It's nicely in the same place that it was before I started, so that's good. And number 3. That helps to get the chips out as you're going along. Otherwise it tends to bind a little bit. All right, here we go. New battery. All right. That one's done. Loosen her up. By golly, I've done it. Looking pretty clean. The real test is the mating piece. We'll see. All right, here we go again. Holes 2 and 3. This one's a little bit more ergonomic for me. Lower. Whoopsie. Still in place. All right. Two more holes. Oh boy. All right, here we go. Real-time test. I also shaved down 2 dowels so I can do the test fit easier. Boy, that's pretty nice. I'll take it. All right, moving on to the angled leg. I'm only doing holes, let's see, 3 and 4. If I did a hole at 2, going down 1 1/16 would get very close, maybe 3/16 of an inch away from this edge, and I want to just stay away from that. So I'm only going to do holes 3 and 4. All right, 3 and 4 again. I tell you, this is nerve-wracking every time. I don't want chips resting on the ledge that this thing is sitting on, otherwise my depth is going to be off. They seem to be all level, so that's a good sign. Haven't moved yet. Two more clean holes. I'm gonna call that 2 for 2. All right, last part of the triangle. Nice and tight. Got another support piece down here because we're about half of this clamp is being used on either side of the support. So I'll do this very gingerly. We're doing 3, 4, 5 this time. Hold 1, 2, 3, 4, 5. All right, again, 3, 4, 5. Okay, this thing has exceeded my expectations. Should firm up with a little glue, I think. Also, once the dowels actually fit correctly. Is the unit itself as strong and durable as the actual Dowelmax? Not even close. Is it cheaper? Without a doubt. Is it capable of being as accurate? So far, yes, at least until it breaks. But that's the beauty of 3D printing. If it does break, just print another one, making sure to incorporate any design improvements that you came up with since the last print. I've linked in the description the location where you can download the STL files, so have at it. I plan on making a separate video about how to make this Murphy desk here, so stay tuned for that. Plans will be linked to that video. That's what I'm talking about. If you're enjoying this video and want to see more like it, please consider subscribing. It really helps the channel grow, and you'll never miss out on new projects. Thanks for watching.